Hello everyone, welcome back to Expert Funda. So in this video, we are diving deep into one of the most elegant problem in mathematics that is called Pascal's triangle, right? And this Pascal triangle will understand through the visualization and we'll go into deep dive to how to implement it. We'll understand the multiple approaches, how to implement it, right? And we'll understand the time complexity and what we should do uh, while we are in the interview, right? And how to uh, go with our approach. Okay, so that's things we will understand in this video. Very first, what we have given is we have given number of rows we have given, right? And what we need to do, if we have given the number of rows, right, it means we have to return all those rows. So this is the problem saying return the first n rows of Pascal's triangle. If this is n rows, right, so means total rows we have to return. And the Pascal triangle, what is happening, each number is the sum of two numbers directly. As you can see, this one is the number. If we'll do the sum, right, with these two number, we'll get the middle number, right? The very first number is static, number two is also static, right? But once this one and one we are getting added, we are getting the middle element, right? That we understand in deep, don't worry. But before that, let's understand, just pause this video, go through the statement and this example so you will understand. As well as the constraint is very simple, number of rows can be maximum 30 we have given, right? So we have to understand what the problem is saying. Okay, so let's understand. So what we have given, right? Let's understand. Very first we have given nums row, means number of rows we have given, right? Means we are given an integer nums, we can say, and that is known as nums row, right? And what is our task? Our task is to return the first n rows, or you can say nums rows of the Pascal's triangle. So for each number in the triangle is the sum of what? Two number directly coming from the above, right? It is very simple. It is saying means if we need to generate the Pascal's triangle up to how many rows? The given number of rows, many rows, right? What we need to do? For example, if we have nums is 5, the output could be what? Output could be, if you visualize the triangle where the very first row is 1 and the second row is 1 2, so these two will be fixed, right? What will happen? So for every number in between is the sum of the two number diagonally. Let's try to understand, like here, if we'll take the very first element, right, this first element is what? The first row, right? Very first row having value is 1. The second row will contain what? 1 and 2, right? So every number, right, that is coming next, that is the middle number, right? So every number in between the sum of the two number is diagonally, right? So 1 plus 2, what we will get? 2 we will get here, right? But this 1 and 1 will be fixed. Next, if I need to write down to the next row elements, means we have to find how. The 1 plus 2 we are getting 3, this 1 plus 2 we are getting 3, right? We'll keep doing that. Let's suppose for the first two element we'll do the sum, we'll get what? 4. This first second two element will do the sum, we'll get what? 6. And this 3 and 1 will do the sum, we'll get 4. I hope you understand, right? Means very first row, if we represent it, what we are getting? We are getting 1. Then this 1 and this 1, if we'll do the sum, what we will get? We'll get 2. This 1 and this 1 is, if you understand what is coming here, is 1, just 1, right? But from this row onwards, if you observe, we are getting this 1 plus 1, we are getting 2, right? Similarly, but this will be remain same. For the middle elements, if we'll talk, this 1 plus 2, we are getting 3. This 2 plus 1 getting 3. But the rest of it is coming 1 1, right? Means only middle element is getting changed, right? And how this is happening, right? If you observe that it is happening diagonally. So this is, if you want this 2, how we are getting this 2 value? This thing, we are getting 1 plus 1, we are getting 2. But from 3, if you do the sum, 1 plus 2, we are getting 3. This 2 plus 1 plus 2, we are getting what? 3. So diagonally it is happening as a kind of diagonally. So for very first, this is fixed, right? But to get this 2, how we are getting to say this? This 1 plus 1 getting 2. This 1 plus 1 is getting 2. Can we say that? Similarly for these 3, right? How we are going to get the value? This 1 plus 2, we are getting what? 3, right? And this 1 plus 2, we are getting what? 3, right? Like this. Can we say that? Means every number in between the sum of the two numbers is coming from diagonally, right? So can we write for row I and j, right? Row I minus 1 and j minus 1 plus row I minus 1 j. Can we say that? So if we'll represent this in here, let's suppose I will represent this value, right, in the grid. We'll call at a 1 1 1 1 1 2 1 1 3 3 1, right? This is your I and this is your j, right? So very first, if we'll put on the formula that we have here, right? Now what we call, we'll say row I and j. So for these two, let's suppose I am talking about these two, okay? So these two, okay? To get these two, but where is the cell value? We have 2 and 1. This row is 2 and column is 1. It means we have to do what? Row I minus 1 means 1 row is now 1 and j is what? 1 minus 1 is 0. Similarly, row I minus 1 means 1 and j will remain same, right? So if we'll take this, so this 1 plus 1 means this row 1 0 is this and this 1 1 is this one. If we'll do the sum, right, means we'll get this diagonal value, right? And so similarly, if we'll apply 3 and 1 means we are talking about this is the row 3 and this is the value 3 we have. If we'll calculate this value, how we'll get it? We'll get 2 0. Who is at the 2 0? This one is at the 2 0, right? And who is the 2 1? This is the 2 1. Understand? We'll add it here. Similarly, if we'll take 3 and what you call 2 at row 3 and 2, what we will get? Means we are talking about this value. Means what we need to do? Row 2 2 1, right? Means we'll take this 2 and then this value row 2 and what you call 1 2 2. It 2 will remain same, right? Because this is same. Means we'll talk about row 2 and 1 plus row 2 and 2 will remain same, right? These two value we have to add it. So if you observe that, means that the formula that we are talking about is correct, right? This formula is correct. Can we say that? Means row I j is equal to row I minus 1 j minus 1, right? Means if I have to find these two, means row I minus 1 means what? This one, this row. So I minus 1 and this is j minus 1, right? So we'll take j minus 1, right? Similarly, if we'll take the row and j, we'll take this value. Means these two value will add here. Let's call it for 3, right? When if row 3 we have here, sorry, give me 1 second. Okay, means if I'll take these 3, we have to take what? This is row 3 and this is the value we have to take, right? Means 1 and 2 for these 3 and for these 3, this 2 and 1 will get the 3. Means we'll keep applying this formula, we'll keep getting the next value, next middle values, right? So can we say what is the intuition behind the Pascal's triangle? So the intuition behind the Pascal triangle is, for each row we will build the previous one and we'll think recursively. For the row 0 we have value 1, for row 0 1 and 1 is 1 1, right? That is fixed. Now start with the row 2 where the start and end with 1 and the middle is what? 1 plus 1 is 2. So we can say 1 2 1. Means this start will be 1, end will be 1. But the next value will what become? 1 plus 1 is 2, right? Similarly, for the middle, the start and end will remain same, right? only middle will get added, means this 1 plus 2 and 2 plus 1 will get what? 131, 1331, right? So if we try the bottom up approach, right? In the iterative way, we use the nested loop, right? So for the outer loop, it will build each row, right? And inner loop will fill the number using the formula that we have seen, right? So let's understand through the code, right? So very first, this is given, and this is the function that we have to generate the what you call all the rows, right? And list of list means we have to return the grid. Okay, means all the rows is in the list, right? And each list will be the list of list. Okay, means we have to return this result. So we will create this result first, and we'll finally will return this result. For each element, for each rows, we have to start the rows from 0 to nums rows that we have given, right? Means you have given 5, we will go to 0 to 4, right? Then we'll create a row. Each row will be added here if we'll find the row, right? So let's understand, if when we have j is 0 and I is less than equal to 1, means, sorry, so when j is 0, right, means the column is 0, right? And we will go maximum by what? The given I. Means, let's suppose, what I'm going to say, if we have let's suppose I'm talking about this one that we have seen, and okay, let's suppose this is your row 0 1 2 3, can we see that? And this is your let's suppose I, this is nothing but your I. Okay, this is your I, and j will take this side, so we'll take 0 1 2 and 3. So this is your j, 0 1 2 3, like this. If we are talking about the row, let's call, we have 4 rows we have, we'll take one more extra here, can take one more extra here. Okay, like this. So if we'll go 0 to 4, like we have given, means 0 when I is 0, right? J will be maximum 0, means only one element will be there. That is why when I is 0, J will be maximum till 0 itself. Very first, when I is at row 1, right? When I is at row 1, it means what? There will be, when it was at 0, we got I and j will be till 0 0. When I become what? 1, it means it will go till j will go till the j. I hope you understand. So this is the loop it is saying. Now understand, when j is 0 or j is equal to I, in both condition we add to 1, means the first, let's suppose for the row 2. So row 2, let's suppose what we have here, row 2 is j, let's suppose j is 0. When j is at 0, we'll store what? We'll storing here what is 1, correct? Similarly, for all the j, what we will put? Just think, if I we have to go till all the row, means all the j when it is 0 will add what? Will add 1. When j is equal to I, means when I means, let's suppose j is at 1 and I will go maximum is 1, so we'll add here what? 1. So all these 0, we understood that we will put what? We'll put 1, that we have put, right? When all the I is equal to j, when j is equal to I, for this case, let's suppose what we have added, I and j both will be 1, right? So we'll add 1 here, right? So next we'll go the less else, but after that, before that, we know that we will get what here? 2, and here what we'll get? 1. Why we'll get 1? Because for row 2, right, when I is at 2, right, the j maximum will go to 2, so we'll add here what? 1. Similarly for 3, we know that here what we will get? we'll get I and j equal, we'll add 1. Similarly for this row, we know that we will get here what? I and j is equal to 1. So we'll fill these values in the first else condition. I hope you understand, right? Means the first element and the last element we will fill like this. What about these values? What about these values that we are seeing? So if this is our middle element, right? What we need to do? We have to apply that formula that we have seen, right? Means I minus 1 and j minus 1 we will get from the result. But what is on the result? Because we previously we already added on where? On the result, right? So we can get it from where? We can get from there, right? So once you see, once this for loop is completed, inner for loop is completed, what we are doing? We are adding on to the result. The result is already containing the previous set. Let's suppose I'm talking about the row 2. When we'll come to the row 2, means this row 0 and row 1 is already on where? On the result. So we can get the result from there, right? Because result dot get I minus 1 dot get j minus 1 will get 1 here, right? Similarly result dot I minus 1 and get j will get this one, and then both will do sum, will get 2, right? So once you get the sum 2, you will add onto the row, and once this row this j is completed, we'll add where? On the result. So this loop will keep going until everything's done. I hope you understands, right? If you have any doubt, please ping me in the comment box. Okay, so I minus 1 j minus 1, the grid first result, right? And then grid first and its next column, right? We'll get like this, and we'll keep adding the sum, and we'll keep doing that. I hope you understand. Let's understand other possible approaches, right? We know this is a recursive approach, right? That if we will apply the recursive approach, it is easy to solve this type of problem, but this is not efficient for the larger problem. Okay, so if you want to do the recursion, right, we can use what? Recursion by using the computed values. So to compute the values, but it is not efficient. First of all, I will recalculate the same value again, right? So if this is a function, Pascal row and column will take, right? Just what you need to do, for when I let's suppose column is 0, right, and column is the last one, means both are same that we are talked, right? Will return 1. Otherwise what we will do, just will do row minus 1 column minus 1, and then row minus 1 column. This is the recursive approach that we will try, and will return the result. But this is a recursive approach, right? You know the number of rows, right? If you, let's suppose we have 5 rows we have given, right? So if we'll keep minusing what till the row is 1. I hope you understand, right? So this is not efficient. Let's understand other approaches. So if you apply the combination formula, NCR, right, the probability things, right? So for each element at index j, right, we can choose how NCR is the formula. Means if number of things we have given, and we have to choose numbers of r, how we are going to do? Factorial n, right, divide by factorial r, and factorial n minus r, we have to multiply it, right? Then we can pre-compute the factorial by using the recursive formula, right? How NCR will do iteratively, right? For let's suppose combination will take from 1, and we'll say let's k will start from 0 to k less than equal to j and k plus plus, right? Then we'll find the combination that we have seen, combination I minus k by k plus 1. So this is the combination formula that we can compute our all the combinations. Okay, we'll talk about it. If you want, let me know in the comment section. I can explain you, right? But I have not explained about the time complexity. Okay, give me 1 second. Come back to the okay. So what do you think? What is the complexity here? Just pause and think what the possibility is here for the complexity. So one thing we can see here is that very first we are using the iterative approach, right? The bottom approach, okay, where I start the for loop, very first for loop. This for loop will start from 0 to number of columns, number of rows, okay, and inside that there is another for loop that start from 0 to the I, means we are in this, what we are doing just, right, we are computing each element in row I. Can we say that each element in row I means outer loop runs how many times? Nums rows time, right? And inner loop will go how many times? Just you can say I plus 1. If this is I goes to nums of rows, means inner loop runs I plus 1 itself, means 0 to I we can say maximum, right? So the total operation, if you tell how many operation will be there, let's say 1 2 3 and so until where number of that rows we have given here. So if apply this formula, how we'll get it? The, let's call it this nums rows is a n, right? We'll just multiply n plus 1 by 2. This is the formula, right? The mathematics, right? So total operation will find what? N into n plus 1 by 2, right? It means this is coming what? N square, right? Means nums square, nums rows square, we can say that, right? So it will take O of n square. Okay. What about the space complexity? Because we are storing all the values, right, on here, because we are storing all the rows in the list of list, so we'll take it's also O of n square. I hope you understands, right? But if you use the recursive approach that we were talking about, this one, what we will get here? Think here, as we see, we are passing these two values, right? And recursively we are calling this function again and again 2 times, right? Means without memorization, if you know the DP, right, we are not using here memorization, right? So without memorization, it become a huge sub problems. My exponential time, it will keep going, right? Means it will take what? O of 2 to the power n times, we can say, in the worst case. Let's suppose n is very worst, right? Or very large, right? So it will become what? Worst case. And that is why if without memorization we will use, so it is giving a exponential type of n times, right? Of n times of 2 to the power n, sorry. Okay. But if you apply the memorization DP, let's suppose you store the value somewhere, right? It will take what? O of n square, because we are pre-calculating the value and we are storing somewhere. Okay. But the space complexity will come same, O of n square. Okay. So both, either you are using the recursive approach and the previous approach, right? Both approach will take O of n square if you use the DP here. I hope you understand, right? Let's understand the other approach, the combination approach, right? What we are doing here, see, combination start from what? K to, it will go to till the j. It means for each element, right, what we are doing here, for each element at index at j in the row I, right? So this is in row I for each index j. How we are calculating the value, right? See, ij, we are getting what? This value, the nr. I just see we are treating I as a n and j as a r. So we'll get what? This factorial. This factorial. So if you apply on the what you call, let's suppose we have c, I and j, right? How will we make it? So I factorial will say into what? J factorial, and then we'll multiply j minus 1 factorial. Can we say that? Just you apply on here, right? I and j. So if all the n will become what? I, and all the j will become j, right? Means we want to compute each element using the iterative NCR, right? NCR, remember? So it will take O of n square, O of n square, because we are iterating over this. Since we will compute how many rows, number of n rows we will compute, right? It will be faster in the practical, right? Let me know in the comment section that you want to understand by pre-computing this or this formula, right? I'll create another videos and we will understand there. Okay. Very first, right, we have tried the iterative approach. We have used the nested loop, right, where we got the time complexity of n square and space is also n square, right? If you'll not do the memorization, if you apply the recursive formula, you will get exponential value 2 to the power n, or the space will be of n itself, right? But if you apply the memorization, right, you will get what? O of n square, right? And space is also O of n square. But if you use this combination formula, right, we'll get what? O of n square, right? In the even in the worst case, right? And a space will also O of n square. It will good if there is only one row, you will get O of one time. That is for sure. Okay. Anyways, I hope you will like this video, and please give thumbs up for this video, and please subscribe this channel. Please support Expert Funda, right? Because you are the only viewer. I'm supporting writing the content in such a way you can try to you can understand. I can make the very video in the very simple way, right? But I'm trying to help you.